Hello all, in this video we will be learning about epicycloid, how to draw an epicycloid in the AutoCAD software. So what do you mean by epicycloid? Epicycloid is a term which is rolling outside of a circle of a diameter. So if you see the sketch here, there is a circle here, there is a two circles, one is larger circle and another is a smaller circle. This smaller circle will roll outside of the larger circle. So this is a circle, it will roll from down to bottom. So this is called one revolution of the circle, and we have to find the angle made by for one revolution we have to calculate. So in this problem, circle of diameter, smaller diameter is 50 mm and larger diameter is 180 mm. So smaller circle rolling outside, so we have to draw the tangent and normal at 135 degrees from the center of the directing circle. So this is our directing circle. Based on this direction, this generating circle will roll. So from the center of the directing circle we have to take a 135 mm radius and we have to cut the point. Okay. So same question can be asked in another way or another manner. Here they haven't mentioned any term called epicycloid. So they are asking us to name the curve. So in this problem, 50 mm diameter rolls on outer circumference of another circle. So we have to see the term called outer. If you see the term called outer, then we can know that it is rolling from outside of 180 mm diameter. Here we have to trace the locus of the point on the circumference of the rolling for one complete revolution. So here we have to roll, we have to check only for one complete revolution. In this sketch, it has rolled 3 times. So this smaller circle has rolled 3 times, but here we are making only one complete revolution of the circle, and we have to draw the tangent and normal at 135 mm from the center of the directing circle. Then you have to write the given data like name of the curve is epicycloid and diameter of the generating circle or smaller circle is 50 mm, and circumference we have to calculate the circumference. This circumference is p to q. So the circumference of circle formula comes as 2 pi r or pi d. 2 pi r or pi d. So if we calculate in AutoCAD, we'll get pi into 50, we'll get 157.07 mm. Next, diameter of directing circle. So diameter is 180 mm. So here we have to calculate the theta. Until unless we calculate the angle, we cannot make the precision. So we have to calculate angle. So theta comes as small d by capital D into 360, like 50 by 180 into 360. We have to calculate the angle. If this angle is wrong, then your complete problem is wrong. And in some other problems, they'll give the diameter is 40 mm and outer diameter is 200 mm. Anything they can give. So you have to calculate the angle. This 100 angle is not fixed angle. So based on the problem, for this problem, it is 100 degrees. For other problem, it may be 120 degrees. You have to calculate the angle. Then only you have to solve in AutoCAD. Okay. So we have to take a tangent at 135 mm from the center of the diagonal circle, and this is the sketch we have to draw in AutoCAD. Okay. So we have to open AutoCAD application, type the question, and then we have to start. Take a circle, center and radius. So the radius comes as 25. Enter. So this is a smaller circle. So we have to take the radius and we have to divide 12 equal parts. Draw a line from end point to center of the circle. Select this line, go to polar array. In the arrays, go to polar array. This specify the center point, so go to center point, and number of items are 12 and enter. So we are dividing into 12 equal parts. Then we have to take the radius of this larger diameter. So you have to on the ortho. The radius comes as 90 because diameter is 180, radius is 90. And we have to take it at an angle of 100. Inside the internal angle should be 100. So this is 180 and this normal straight line is 180. So 180 minus 100, it comes as 180 minus 100 comes as 80. This 80 we have to divide into 2 equal halves. So it will comes as 40. So we have to rotate this at an angle of 40 degrees. So select the object, click on rotate, and here we are rotating clockwise. Clockwise is negative and anti-clockwise is positive angle. So we are rotating clockwise. So here we have to type rotate at an angle of minus 40 degrees. Okay. Then we have to copy it. You have to use the command called mirror. Select the point and click on no. Then you have to make the command called mirror. So we got an internal angle of 100. If you have any doubt, you can go for angle and you can measure the angle. The angle should be, the internal angle comes as 100. Then you have to use a command called arc command. In the arc command, you have to select center start and end. Click on the center, click on the starting point, and click on the end point. So this curve, you have to draw the curves from one point to other point. Select the curve, use the command called offset and enter. Then you can click the different points. Wherever you want to click the point, you can click the points automatically. Select the point and drag it so that automatically this will be created. Okay, select the point correctly. Okay, and top you have one more point. This point you have to place it correctly. Okay, and you have center. This center also you have to create. So again, click this curve and move it to the center. So this is our center. Come out of the command, click escape and come out of the command. This is our center. So this will be in different color, because to differentiate with the other things, will make center with the different color. Here you have to select the color as red. So select the circle, select this divisions and delete. We no longer required it. And take a line and draw the line from this point to this point. Okay. Then use the command called extend, ex, double enter, and extend the this curve till the end. Don't extend the center one, extend only the points which are touching. Okay, so you have extended, and this division, this circle, we are doing two equal parts, so that we have to label it into two equal parts. So dt enter, dt text enter, then specify the starting point. So here I need to start my point, so I'll place it. It's asking height is 5 and enter, angle is 0 and enter. So here I'll get the point. So this point is capital P comma 12. Okay, so this will be P, this will be Q, we have to calculate. So this will be P comma 12. So place it, then again click one more point. So this will be your 11, this will be your 10. Make sure that it is not touching the line. Okay, touching the circle, it should be better, it should be outside. So I'm typing 10 again, 10, then again 9, then it is 8, 7, then again it is 6, this is 5, this is 4, this is 3, this is 2, and this is 1. Okay, and this here you have center, so you have to mark this point as C, capital C you have to mark. Okay, so you have marked this as capital C, this you have to mark it as capital D, this you have to mark it as capital D, and here you will get the Q, capital Q you will get here. Okay, so everything should be outside, no overlapping. So that's the reason we are deleting this 10 here. So everything should be outside. If you are the size, you can decrease. If your size is not required of 5 mm, you can make it as 3 mm also. Okay, then you have to select this one center, and this you have to divide into 12 equal parts. So in the command bar, type div, enter, then select the curve, then 12 and enter. So it will divide into 12 equal parts. So for this also you have to give the labeling from C1 to C12, you have to give the labeling. So go to text, multi-line text, and place the text. So this one I have to make it as capital C and 1. This one I have to make it as subscript. So this I have to make it as C1. Okay. So this point comes as C1. So copy, Control C and Control V. So place it. So this will be my C2. Control V, this will be my C3, Control V, this will be my C4. So paste it continuously to the required points, and again you have to rename. Double click and you can rename your required points. So again here also you have one more point. So here, so C12, it's better, I'll writing C12. Okay. So give the labeling. So this is your C2, select it and make it subscript. Again double click the point, then make it as C3. Again double click the point, make this as C4 subscript. C5. Select the C5, make it as subscript, make it C6, make it as subscript, C7, make it as subscript, double click, make it as C8, select and subscript, double click, make it as C9 subscript, double click, C10, make it as subscript, double click, make it as C11 and subscript, double click, make it as C12 and subscript. Okay. So labeling is also important in AutoCAD. So you have done all the labeling. Now your actual epicycloid start. So select the circle and move this circle to C1. Move this circle to C1. If you want, you can off the ortho. Off the ortho. It has to cut the first line. This is my first line. Again pivot, enter and create a point. Okay. Mark the point as P1. Okay. Select it. Move to center 2. Mark pivot, enter, and this is my second line. Second line cuts here. Okay. Then again click the circle, move to C3, pivot, enter and select the third line. This is my third line. Don't cut the midpoint, don't cut the red color line. Compulsory you have to cut the third line only. If you cut the midpoint red color, it is wrong. Go to C4, then pivot, enter and cut the fourth point. Then again click this circle, again go to C5, then pivot, enter and cut the fifth point. Again click the circle, go to C6. So sixth point is at the top. So pivot, enter and click, so that you'll get the exactly. So if you can repeat till C12 or else you can use the command called mirror. Select all the points, whatever the points you have created. Select the point. So this is your and select all the points I have selected. Use the command called mirror, and from this end to this end it has to touch. Okay. Click on no. So automatically all your points are generated. So select the point and again move it back to the circle. This circle should be there. Don't delete the circle. Now you have to use the command called spline fit. So click on draw. Here there are two types. One is spline fit and spline CV. Compulsory click on spline fit and start with the P naught. It will start with the P. So from P it has to touch to P1, then it has to go to P2, then P3, then P4, P5, P6, P7, P8, P9, P10, P11, and again it has to touch to Q. Compulsory it has to touch to Q. Then it will roll certain distance. So click on end tangency. Compulsory click on end tangency, and how you are placing is important. So again move it back to the center. Keep it at the center and make sure that it is having the ending the tangency. Okay. So You got some wrong, so Control Z. Undo, close. So undo. So here close option is there, so don't click on close. Undo. Skip. So this point we can move the end tangency and place it correctly. So that use the command called end tangency and end it correctly. So here we can double click the line, this one, curve, then double click the line, double click the curve, then you will get the fit data. Click on fit data and tangent. Then this should be, this point should be like touching this line. Then automatically your curve got fit. Click on exit. Okay. Select it. Click on fit data, tangent. Select the point. Click it. Click it. And then it will be completed as a tangent. So after closing the tangency, we got the curve. So this is our curve, and we have to also highlight the points. So here again we have to Control C and Control V. So each and everything we have to write it as P1. So this is our P1. Again Control V. Here you have to write it as P2. Then Control V. Here we have to write it as P3. Okay. So like that we have to repeat the curves. So double click. Okay, write it as P1 and select the one and make it as subscript. So this is our select this one. This is our P2. Select it and make it as subscript. Okay. So like that, repeat all the points. Wherever you got the point, repeat the point. Control C and Control V. This point is P3. So double click, make it as P3. Subscript. Okay. So all these points you have to copy and again paste. Control V, 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 Control V. Okay. Don't click the point. Control V. And here you have to write it as P12. Okay. So here only I will write Q comma P12. Q comma P12. Both are coinciding at the same point. So this I have to make it as subscript. Okay. P12. So double click, make it as P11 and subscript. This one is P10. This one is P9. Select and subscript. P8. Select and subscript. P7. Select it and subscript. P6. Select and subscript. P5. Select and subscript. This point is P4. P4 select and So we have done the epicycloid. Now we have to draw the tangent and normal. Now we have to draw the tangent and normal. So the tangent is at a distance of 135. So go to arc, center, start, end. So click the center, starting it at a distance of 135. Enter. Angle where it is cutting here. At this point it is cutting. Okay. So this is the point where it is cutting. So draw it. Or else you can draw A, enter, C, enter. A, enter, C, enter. Click the point. From here you know where it cuts. 135. Enter. And from here you draw the arc. It is cut at this point. So this is our point. So this point you have to rename it as this point. You have to rename it as M. Capital letter M you have to rename. So again go to DT, enter. Here I have to rename it as M. So we'll rename later. So click on circle and center and radius, or else same circle you can mark. This circle you have to move to this intersection called M, and it will cut somewhere at this point. So that point you enter PO, enter, and mark the point. Okay, this point it will cut. So again move back your circle to the same center. Okay, so it is cutting somewhere here. This radius is 15. So from here you have to take the align dimension, and you have to show that it is at a distance of radius of that one. Okay, if you click here you will get align 21, align 25. Escape, double click and make it as, rename it as R25. You have to rename it as R25 and come down command. So this is distance we are taken as radius 25 because here our circle diameter is 50. Okay, so draw a line passing from this X point to this point. Okay, and it cuts somewhere at this point. This point will cut somewhere at this line, bottom PQ line. It will cut somewhere here. So from here you have to draw a line passing here. Okay, so select the line, use the command called copy, select the base point and again copy. So this is your actual normal. Both the lines are normal. Okay, so this is your normal line. Select both the line, Control C and Control V, place somewhere, select both the lines, then use the command called rotate at an, give any base point, rotate at an angle of 90. So whatever the rotation is there, that will be your tangent, and use the command called move, select somewhere and move and place. Okay, so this is your actual thing what you need to highlight. So this is your normal and this is your tangent normal. Again you have to highlight this uh, generating circle, then again you have to highlight the directing circle, then again you have to highlight this curve. What are the curve you are getting, highlight. So right click, go to properties, go to line weight, change the line weight to 0.3. And if you are unable to see the line weight, make sure that your line weight display is on. Compulsory you have to on this line weight display. Okay, then you have to give the labeling. So here I'll give the labeling. So dt text, dt, enter, specify the starting point. I'll specify here height equal 5, enter, and 0, enter. So here this distance is M, capital letter M is the distance. So here this point is X, capital letter X is the point. Okay, and here you will get the letter called N. This is called the normal. So letter N, it shouldn't touch, so come out, make sure that it is not touching the curve N, and this is my N dash. N to N dash is the normal, N dash is the normal, and this is my T, capital letter T, and this will be my capital letter T dash. Okay, so T dash, everything done. So here I have to give the point called T dash. T dash and come out of the command. Okay. Then you have to give some other labelings. You have to give the other labeling. So I'm deleting this extra n. So n to n dash is a normal, t to t dash is the this one. Okay. Then I have to show some dimensions. So of diameter 50. So go to diameter, select this diameter and show that it is dia 50. Okay. And you have to show that the radius is from this line, this radius is 90, r90 you have to show. This r90 should come and touch. Okay, you have to show that this is r90, r90. Then you have to show one more radius of this curve. You have taken at an distance of 135. You have taken the distance of 135 for this one. Where is the curve? This is the line. So this is r135. So I have to show that this radius is r135. You have to show. Already r25 has been shown. R35 190 50 100 angle has been shown. Okay, then your problem is completed. The problem is completed and you have to write the labeling. You have to give the labeling. You have to give the labeling. You have to give the labeling. Such as this is my directing circle. Directing circle. This is my directing circle. Again, this is my, okay, so that one we have to write it as directing circle and this one we have to write it as generating circle. Don't confuse with the directing circle and generating circle. Go to leader. This is my generating circle. Generating circle. This will be my directing circle. It is coming inside. So I will not, I'll use outside. So this is my directing circle because it is directing and generating circle is generating. Generating circle. Then you have to name the curve. The name of the curve you have to highlight. This is epicycloid. Epicycloid you have to highlight and then you have to write which one is tangent and which one is normal. So this is my tangent one. So write it as tangent and again one more. This is my normal. So from here I have to show that it is my normal. And so tangent and normal. So your problem is completed with the diagram and labeling everything. So you can expect full marks for completing this diagram. Thank you all.